I'm Dr. Vinu. In underground cable engineering, the fourth topic in the fifth unit is testing of transmission cable systems. Testing ensures that high voltage as well as extra high voltage cables are safe, reliable, and free from defects before and during service. What is the meaning of testing of electrical power cables? The various components of the cable should be tested during the varieties of testing in underground cables. The types of testing on the transmission cables are routine test. This type of test are normally done during manufacturing. It consists of varieties of tests like conductor resistance test, high voltage test, partial discharge test, as well as insulation resistance test. The second test is type test, which is taken in the samples. High voltage withstand test, heating cycle test, bending test, and impulse voltage test. The third test is pre-commissioning test. This test is normally conducted after installation but before energizing the cable. It consists of insulation resistance test, high voltage DC or VLF test, sheet integrity test, continuity test. The fourth test is commissioning test, normally, which is used for on-site acceptance. It consists of high voltage AC test, partial discharge test, which confirms that installed system meets design standards. Next test is maintenance or in-service test. This is performed periodically to monitor cable health, loss and emission test, online partial discharge monitoring, thermal imaging, and sheet test. This tabulation represents the varieties of test as well as the stages which is used to test. The next topic is underground system fault locating. Fault locating in underground cable system is crucial because the cables are buried and unlike overhead lines, faults are not visible. Special testing and locating methods are used to quickly detect and repair faults. This diagram represents the underground cable fault locator. These are the various fault locators which is used to locate the fault based upon the cable distance, cable disconnect, as well as cable contact. Then root locators or locating the faults by means of root tracing, center line, and depth. The circuit diagram represents underground cable fault distance and their types of fault in underground cables are open circuit fault, short circuit fault, air fault, leakage fault. The various stages in fault location are fault detection, fault type identification, rough location, exact pinpoint. Normally, the insulation resistance test, that is MEGA, is used for fault location. That's the second test is incorporated test. Third one is Murray loop test. Fourth one is Barley loop test. Fifth one is capacitance method. Sixth one is pulse or echo method. Seventh one is surge or tumbler. Open circuit faults are used to identify the continuity as well as Murray variables. Air short faults are normally using Magyar as well as Murray Valley loop test. Exact pinpoint can be done by means of tumbler. The field assessment of power and cable systems are testing and monitoring cables in service or before commissioning to ensure reliability, detect early degradation, and prevent failures. What's the need of field assessment? Underground power cables are costly and difficult to treat environmental factors and insulation over time. Early detection of defects prevent outages and extends service life. These type field assessment of cables combines inspection, electrical test, and online monitoring to ensure safe, reliable, and long-term performance of high voltage, extra high voltage cable networks. The major field assessment tests are the first one is visual as well as physical inspection. Second one is insulation resistance measurement. Third one is high voltage testing. Fourth one is partial discharge measurement. Fifth one is dissipation factor or dielectric loss measurement. Next one is time domain reflectometry. Seventh one is sheet testing. Eighth one is thermal imaging and online monitoring. This table represents the various field assessment methods as well as its tools. Thank you.